So with these help sessions, first we'll just ask, are there any questions? And if y'all have particular questions or topics that you want to deal with that are just like on an exam or in the class that we did, then I can do that. But if you don't, then I'm gonna work through some problems that I think are probably good. So first, are there any questions in particular right now? Yeah, Haley. Magnitude, yeah.
Where do you get the numbers from?
Okay, well let's do some practice problems like that, like problems that I ask on the test. So like for example, you're going to have one or two, usually two estimation problems. By the way, the number of problems that I give on each topic for every test is usually the same. So like for example, this test was fall 20, this was last fall. So there are two questions about estimates in order of magnitude. The first one, oh, and also these, just to remind you, these are all on the website right here under Physics 101 exams. Great place for you to practice with for your quiz next week on Wednesday. Only chapter 1 on that quiz. And there are the PDFs and then also solutions to those. So let's do number 1 and number 2. This is from fall 20. Here I give you a shape and I show you what is the length of an imaginary unit called the rambit. And I ask you, what is the area of this shape in square rambits? So this is the length of my object, and then I want you to find the area of that object by applying what is the length of one rambit. So I can see here that this is about 2 rambits across. You see how that length that I drew is the same as this length right here? So this is 1 square rambit. It's 1 rambit by 1 rambit. That is what is area, right? That's how we find areas. We multiply the length times the width. And this is also 1 square rambit. If you imagine this part up here, these two combined, this is going to be a half a rambit, because if you see, if I put a square like that, then that's a full rambit, and I'm taking half of that. So this is a half a rambit, and then this is another half a rambit. So the answer for that would be 3 rambits squared. So Haley, the answer to your question there, in that problem, is that you get the numbers from applying the length that I give you. Now that's true too when I'm giving you, say, centimeters or meters or kilograms, but in that case it's a little harder because you have to imagine what is the length of a meter or a centimeter, or what is the mass or maybe the effect of the mass, the weight of a kilogram object, and then apply that to some object that you're familiar with. And here, number 2 is a good example of that. I ask, what is the area of a typical space bar on a computer keyboard? Now I'm looking at a space bar right here, and I know that a centimeter is approximately the width of my pinky. And so I imagine, how many times can my pinky fit across the length of an average space bar? Well, if I imagine my space bar, it's long and rectangular, I would say that my pinky could fit about 8, 9, 10 times across the length of a space bar. You think about a space bar and how long it is in your mind, and then imagine how many finger widths can I get across that space bar. What is this length of the space bar, right? The width of that space bar in pinky widths, would you say? It's about one pinky width. So a pinky width, which is about a centimeter, is going to be then 1 centimeter by 10 centimeters, or 10 centimeters squared. So that's where we get those numbers. We can look at some others too if you like. If you look, every test will have slightly different questions that have to do with estimates in order of magnitude. Let's look at the fall 19 test actually. So this is some of the free response, by the way. You're not going to have free response on your quiz, but you will have it on your test. All right, this is the fall 19. What is the approximate volume of a typical coffee cup? Well, think about my coffee cup. I'm going to think of it as a cube or a rectangular prism. And I want to figure out what is the height or the the volume rather of this coffee cup. I'm going to say, what would you say is the width of a coffee cup in centimeters, roughly? It's about this much, but in centimeters, how much is that? I take my pinky, 1, 2, 3, 4, maybe 5, 6 centimeters. I'm going to say 6 centimeters. So my 6 centimeter, I have 6 centimeters there. I have, say, another 6 centimeters there. And then the height of the coffee cup is more than the width of the coffee cup, right? Y'all drink coffee? Who needs coffee? You know what a coffee cup looks like, right? That my coffee cup is typically about this high. Maybe that's a tall one. But it's bigger than the width. And so let's say that the height of this coffee cup is, I don't know, 10 centimeters. You know, I'm just sort of throwing numbers around, and then when I get a result, I'm going to look at the options that I give you that are all different by a factor of 10, and I want to pick the one that's closest to that. So I have 10 times 6 times 6, that's 10 times 36, or 360, or 400 cubic centimeters. So the one that's closest to that is going to be C. Now you might have chosen something different, like you might have chosen 5 centimeters by 5 centimeters by 8 or something like that, or say 12 or whatever. But the point is that you're never going to get 40 cubic centimeters or 4,000 cubic centimeters, because that would be a coffee cup that is 10 times as big or 10 times as small. That you should always get one of the answers that's within an order of magnitude to the right answer. You will get that with practice, like how to actually get the numbers in your head, but you're going to have to think about what is a centimeter, what is a meter, what is a kilogram, it's a couple of pounds, what is a kilometer, it's, you know, like 0.7 miles or so. Let's look at this, number 2. What is the approximate walking speed of a typical person? First of all, how many steps does a person take in a second? 1 or 2, right? Let's just say 1. And then how far do you walk with a step? What is sort of a typical step for a person? A foot? Really? Like that would be, yeah, it's about like the normal walking speed is about a meter every second. So here, if I want to know what is the approximate walking speed, well, I know I take about a step every second, 1 or 2 steps, depending on, doesn't really matter. And so that gives me 1 meter per second. The point is, I'm never going to get 10 meters per second at a walking speed, right? That would be like from here to the door in 1 second. I could run that, but I'm not going to walk it. And I'm not going to get 0.1 meters per second. That's this far. That's sort of what you were saying, right? That's sort of a, I don't know, like an old man walking speed. No. Or somebody that's walking really slow. Haley, does that help a little bit? I appreciate you asking that. Students often really struggle with estimates and order of magnitude. And as with most things in this course, practice. Practice 20, 30 minutes a day. Sit down and say, I'm going to work these 8 problems today. And just focus on those. Try them on your own first, and then go back to the solutions if you need to. And if you get those, then that's great. Move on to something else. Okay? I think that the dimensional analysis is also something that people really struggle with. So let's just look at that. And we have some good examples here. Number 3 and number 4 are great examples. We worked some of these in class. Let's look at number 4 first. We did one very similar to number 4. Let's go back up to the fall 20. Yeah, we'll look at number 3. This is fall 20, number 3. And we did one like this in class today. I want to know, what are the units of R? When you encounter a question like this, and you almost certainly will, when you encounter a question like this, first of all, you want to simplify it the best that you can, although it appears in this question that you can't really simplify it. And then you want to solve it for R. one mistake that students would make here is that they would say, oh, look, I have v on both sides, so I can cancel them out. But you cannot do that because you have a v here in the numerator and a v in the denominator. They won't cancel out. I can't divide through both sides and get rid of the v. So let's just stop that. I know in class we were able to do that, and that is a good first step to see if you can simplify the equation first. But here, we want to solve the equation for r. In order to do that, we multiply both sides by v over x, These cancel, those cancel, and I'm left with r is equal to av cubed divided by xt. Now, we know the units. You might not know these units yet, but by the time you come around to the test, we'll know the units for acceleration is meters per second squared. The units for v is meters per second. X is meters, and t is seconds. So we put those units in for each variable, and then figure out what are the units for r. So I get this. I get a is meters per second squared. I get v is meters per second, but it's cubed, v cubed, so this is going to be meters cubed, seconds cubed. And then I'm going to write the x as 1 over meters. The reason I did it that way is just to pull it away from those two things that were in the numerator and put the x into the denominator. And I'll do the same for t, 1 over seconds. So goodness, I got a lot of meters in the top, although I get a cancellation there. Those divide out. But I got meters cubed divided by seconds to the 2 plus 3 plus 1 seconds to the 6. So A is the right answer for what are the units of r. You'll probably have a question like that on the exam, almost certainly, where I ask you what are the units of r. And I can tell you that with almost certainty because if I look back at all the past exams, there's almost always a question like that. There's also almost, oh yeah, Kennedy. We did it in class because we were dealing with a different equation. So let me show you. For example, I could rewrite. This is going to be a different question, but it's going to be similar just to show you. So let's say instead that this was av squared over t times rv over x. Right? And so what we did in class, I think if I understand your question right, is that we said I can divide through both sides by v and get rid of that v on the right-hand side. I can do that before I ever solve for r. I just want to simplify the equation as much as possible. And in class, we were dealing with that equation that looked really complicated, but when we simplified it, canceled out variables that were in the numerator and the denominator or on either side of the equation. When we canceled those out, the equation became really, really simple. Okay? That is what you were asking, right? Okay. Let's see if this one down here, it might be similar. Oh yeah, so look here on number 4. Again, this is fall 20. On number 4, I wanna know what is the which of these equations are dimensionally correct. Let's just look at number 1. You'll tell, actually, by the time we get to the exam, you'll know this equation, so you'll know that it's dimensionally correct. That's actually one that we'll deal with. And likewise, we will have experienced this equation. You might not know it, but it'll probably be familiar to you. Both of those are dimensionally correct. But this one at the top is it's different. So the first thing that I can do is look to see if there's a variable that will, oh no, never mind. Yeah, let's not do it that way. I want to get rid of the constant, so like I can forget about the 3. Yeah, let's do it this way. Okay, and then I'm going to put in my units for each variable. So x is meters, t is seconds, but x is squared, so it's meters squared per second. What I did right there is I just put in the units for this side of the equation. X squared over time, meters squared over seconds. Now, A is meters per second squared, that's acceleration. X is meters. I'm going to put it over 1 just to remind me that that's in the numerator, but you might not need to do that. And then seconds, I'm going to put it over 1 like that. then I can go through and cancel out things that I can cancel out. I can get rid of this, gets rid of one of those, and I'm left with on the right side meters squared per second, and then of course I also have meters squared per second on the left hand side. So that is a dimensionally correct equation. Okay? We can look at some more of those, but let's just sort of scan down through the rest of chapter 1 questions. I'll show you how you can tell where the end of these questions are. Just a second. So this, for example, is the end of chapter 1, and I can tell because I have a unit conversion here, which is in chapter 1, and then here I have a kinematics question. We're going to get to this on Monday, but that's in chapter 2. So that's where the break is between chapter 1 and 2. And if you're not sure about where that break is in an exam, just shoot me an email and I'll tell you. Okay, tell me your name again. Emily.
So I don't know if this is like a stupid question, and it's the third one that we were looking at for dimensionally correct.
Mm-hmm.
I don't understand why that's right.
Okay. Yeah, the reason I didn't work through it is because by the time we get to the exam, you will have seen this equation. And so I hope that maybe you could just say, oh, that's one that I've seen before. But let's go through anyway and look at how it's dimensionally correct. First of all, I can say that these two terms are dimensionally correct because they're both velocity squared. So they're both meters squared per second squared. Velocity, remember, is meters per second. If I square it, I square both sides, the top and the bottom. And then I also want to do the 2ax. Now the 2 doesn't count, so I'll just get rid of it. A is meters per second squared. X is meters, so I have meters squared per second squared. And we're dealing with an equation like this where I have multiple terms that are adding up. I want to make sure that each term is has the same units. Emily, is that, you seem to be processing. Are you processing?
Yeah, it's processing.
Okay. No, it has to be the same exponent. I said it was the same because right here I have meters over second squared. That's the same as meters squared over second squared. That's why it's the same, because it's the same units and the same exponents. Must be the same exponent. Okay? Okay. So let's go down to the next page. I showed you where the break was. You're going to have on the quiz, actually, you know what? Look, this first couple pages is probably a pretty good indication of what you'll have on your quiz. All right? Because it's probably going to have all the topics from chapter 1. You'll have trig, you'll have sig figs, you'll have sig figs of an expression like that, a mathematical expression, and you'll have some things about standards. The questions about standards, you need to know what makes a standard appropriate, accurate, accessible, and unchanging. We talked about that on day 1. And you need to know what are the standards for mass, length, and time, as well as what are the units that we use, the MKS system. Yeah, William? No. Ron. Huh? What's your name?
So there was that question in the Untitled booklet about like you said, like what makes a standard correct.
Uh-huh.
And it just like the wording. Could you like explain it again? Like it was a quick question.
Yeah, let me pull it up. Elena, did you have a question too? No. Okay. And it's Michael.
Yes.
I don't know if it'll let me pull up 2 notebook files. Let's see.
Now that I'm reading
It makes sense now?
I guess it's just I read it again and like slowed myself down and it makes sense, but if you still want to explain it.
Okay. Yeah, you have to be careful when you're answering questions that you understand exactly what it's asking. So this is a good exercise. I'm looking for reasons that make them not appropriate, right? So these are reasons that would invalidate a standard from being a standard. If a standard changes, that's a reason for it to not be appropriate. If it's not available, that is, it's inaccessible, that makes it a reason. But if it's based on some obscure physical constant, most of our standards are. All of them, in fact, are based on physical constants. And it doesn't matter if it smells bad. I mean, who cares, right?
So, like, for example, just like, this is out of pure curiosity, how is a cesium atom available to us?
It's not necessarily available to you, but it's available to anybody that wants it. Okay? So, you're right. You can't go down to Walmart and pick up a cesium atom, but you can go online and pick up an oscillator that's used for timing. Astronomers, scientists all around the world can just go, you can buy this device and it has a cesium atom that vibrates in it and it measures that frequency and you use that for your time standard. That's actually a pretty common device to buy. Okay? Yeah. Okay, good question. Yeah, Maya.
Question about one that's in exam one that is in the booklet.
Okay, what year is it in?
First fall 2016.
16.
And it's number
Number 8? Alright, shoot. Oh, do you want me to just work it? Or you have a particular question?
yeah.
Okay. You're probably going to have to do this on the quiz/exam. This is where you're converting one unit to another. And this is like that video, the little 2-minute video I sent out. This is like what that is, where you're converting units with powers. I'm converting a volume flow rate of 5 liters per minute. And I want to convert it into cubic feet per second. That should be a C right there. Cubic feet per second. So I want to convert it into feet cubed per second. And I give you several conversion factors here. First of all, let's convert my liters. This is my conversion factor. I know that 1 liter is equivalent to 0.001 cubic meters. So as I'm doing this conversion, that'll get rid of my liter unit and leave me with cubic meters. But I don't want cubic meters, I want cubic feet. And so my feet conversion is over here. I have 1 meter here and 3.28 feet. Now this is where it gets a little tricky because I have meters in the denominator, but cubic meters in the numerator. And I want cubic feet in my answer. So that means that I'm going to have to cube this unit. Notice I didn't have to cube this conversion factor because a liter is equal to so many cubic meters. Like a liter is really just another way of saying cubic meters. Like a milliliter is a cubic centimeter. It's just a measure of volume. And we can express it in terms of liters, or we can express it in terms of cubic meters or cubic centimeters or whatever. I don't know that cc is a milliliter. Cc, a cubic centimeter, is a milliliter. So I cube that conversion factor. And that leaves me with my cubic meters cancel here and here. That leaves me with feet cubed, or cubic feet, per minute. But that's not what I want either. And so I do 1 minute, and then I think, how many seconds are in a minute? I don't give you that conversion factor, but you should know it. 60 seconds in a minute, and then that gives me the answer. Okay? Emily. Emily? Elena. Oh, you're Emily. Elena.
I did this about an hour ago, and I worked out the same way when I plugged it in my calculator. I got the answer as C, and your video said it was E, so I'm not sure.
I might have had a mistake. What did you say the answer was?
I got C.
No, it's A, 0.6.
It's a video says
What'd you get? Maybe I made a mistake then. Let's see. Oh yeah, I didn't put in the 0.001. Alright, 5 times. This is going to be a good lesson, though. I'm going to tell you why in just a second. I get 0.003 E. What's the right answer in the back? Yeah. And if I put that in my calculator, I get E. Probably you didn't apply this cube right here correctly. Or maybe you got some variable in the numerator or the denominator incorrectly. I will warn you that on my exams, like on any good exam, for multiple choice questions, and you know, if you're pre-med or pre-professional, whatever, those various standardized tests that you take, this will be true there too. That if you get an answer, doesn't mean necessarily that that's the right answer. Just because you get it doesn't mean it's the right answer, because most of these options, I've gone through and I've calculated the errors that students commonly make, like they leave the cubed off, for example, and I put that answer. So just because you get an answer that's on there doesn't mean that it's the right answer. In fact, if you have a conceptual problem, then it's probably not the right answer, because you've made a common mistake that, I mean, I know what mistakes students make, so I'll give you those answers just to see if you really know what you're doing. Okay? I say that, I don't want to scare you, because, you know, students can do really well. They often do really well on my test. It takes a lot of practice. You read that thing that students said about how they made an A in the class. Almost all of them say they practice. They come to class, they listen, they participate, they sort of pay attention when they're in class, and then they spend a lot of time outside of class practicing. That's what you got to do. And I know that many of you, like, you've never had to do that, or you haven't had to do it much, but you'll definitely have to do it in this class. Wait till you get to biochem. You're going to have to do it a lot more in biochem. Okay? All right. What else? Standards, unit conversions, sig figs. Clear on this, how to do something like this? And there are two rules at number 5 here. You know, it's fall 16. Number 5, the two rules are when you add numbers, you keep the lowest number of what? Decimal places. Very good. So here I would get just one decimal place, so that's going to be, well, it's going to be 15.65 or 15.7 divided by 4.92. And then at this point, it doesn't really matter what the answer is. All that's important is how many sig figs do I keep. When you're multiplying and dividing, I keep the lowest number of what? Significant figures, yeah. So the answer there is going to be 3, because both of those numbers have 3 sig figs. Kennedy?
I had did one by myself in one of the old exams. We did it differently. Like I started out converting either the bottom or the top. We got the same answer. There's no problem with that.
No, of course. You just want to make sure that you get all your units laid out correctly so that they cancel out properly. You know, high school teachers will often teach it this way, where you create like a little ladder, right? You might have done that before. I don't use that because that's not really proper mathematical symbols, but it's okay to do that, where you put, you know, meters per second, whatever, meters, miles, you do your conversion factors on that. I do like that method because it does allow you to sort of get the stuff in the right spot, which is why I do the seconds over 1, for example, to help you think about where your units are. So yeah, you can do it in a different order. That's fine. Let's do number 3. Let's just look at this question right here. The v equals square root of ax. So v is meters per second. Square root a is meters per second squared, and then x is meters. So on this right-hand side, I have the square root of meters squared per second squared, which is equal to meters per second. So then I have the same units on either side. Number 3 is a good one too. Let's do it. This one right here. Can you look at number 2 and tell me if it's right or wrong? Don't write anything down. Just think about it. Look at it. X is meters. A is meters per second squared. What happens if I multiply that times second squared? I'm left with meters, right? Meters per second squared times second squared is meters. V is meters per second times seconds leaves me with what? Meters. So is that dimensionally correct? It is, yeah. I warn you on your test, though, that if you try to think through problems, it's good to think, but that it's often a lot better to write down what you're thinking, okay? Students will often work their problems in their calculator, and I find that those students often don't do very well, but they might be B students at best. But the students that do really well are the ones that are writing a lot on their exams. That will help you to think it through. Let's look at this third one. All right, X is meters. V times T, that's meters per second times second. So far I'm okay. Minus the 3 doesn't count. I'm going to get rid of the X because it cancels out with that. Meters per second is velocity, but it's squared. And then A is meters per second squared, but it's going to be second squared over meters. 1 over A, so what I have, 1 over meters per second squared is equal to second squared over meters. Let's go through. This cancels, that's good. These cancel, and this M cancels with one of those in the numerator. So I have meters all throughout, so that one is correct. Or excuse me, this one is correct. Okay? I know that probably a third to 2/3 of you, that sort of terrifies you a little bit, but you're going to have to know how to do it for the test, and then it will help you moving forward in the class. Madison, is that right? Madison?
Is that like 1 over A right there?
Yeah, that's an A. Mm-hmm. Oh, I was just showing you that right here, I have this A in the denominator, and I wanted to show you that the units for 1 over A are second squared per meter. All right, so 1 over A is 1 over meters per second squared, but then that meters per second squared, when I bring it up into the numerator, it flips. Right, the second squared comes up top and the meters is below it. You'll almost certainly have to do that little flip on the test or quiz at least once, where you have a unit that is a fraction in the denominator. So you're going to have to flip it when you bring it up into the numerator. Somebody had their hand up. Is that you, Emily? Kennedy? Kennedy? Yeah.
The one above it, how would you, like, those are not, like, they seem practical and easy, but at the same time, it's just hard for me to imagine it.
Oh, the desk?
Or the mass of the desk.
The mass of your desk? Okay, well, remember how many kilograms a person is? About 70, yeah. So a typical person is about 70 kilograms. Does your desk have more mass than a person? No, So I'm going to get rid of these. And a kilogram is really just like a couple of pounds. And so that gets rid of that one. So B has to be the right answer. That's really the only one that's reasonable. Okay? It is practical. I know that y'all don't use the metric system very much, but it is practical to have in your mind a translation between the metric and the British system, because as you go into your various STEM fields, you're going to use a lot of metric units. It's just sort of the way of the world. Okay? Practice, practice, practice. You'll get the hang of it with practice. I can't, like, if I speak to you about these things, y'all are never going to get it. It's really outside of this room when you're sitting down by yourself, banging your head against the wall, trying to figure out these problems. And they will come. Like, if you put in the effort, they will come. I don't care how confusing it seems right now. You will eventually become more comfortable with it. I promise. Okay? Trig. Let's look at trig just a little bit. So you will have 1 or 2 trig questions on the quiz and probably 2 or 3 questions on the test. So just know your SOHCAHTOA, know your Pythagorean theorem. Here, if I wanted to know the angle theta, what would I use? What trig function would I use to find the angle theta? Tangent, because I have the opposite side and the adjacent side. I can calculate what the hypotenuse is, but I don't want to do that. If I want to know theta, I would say tan of theta, SOHCAHTOA, is opposite over adjacent. That's the TOA part, right? T-O-A. And so tan of theta, or rather theta, is the inverse tan. I take the inverse tan of both sides, and it gets rid of that tangent on the left-hand side. Of opposite over adjacent, that's 4.2 over 5.0. And then that angle is whatever it is. Do you know what the angle is without calculating it? Look at that triangle. What do you think that angle is? I'll give you a hint. It's really close to being an equilateral right triangle. An equilateral right triangle is when the two sides are the same and the angles are what? 45 degrees. So without calculating that, can you tell me what is the angle theta? It's going to be 40. Very good. The reason I know it's 40 is because I know it has to be close to 45 because this is close to an equilateral right triangle. So that gets rid of this one and this one. So it's either B or D. And the reason I know it's B is because it's opposite the smaller side, it's going to be the smaller angle. So this one then is going to be 40 degrees. And what's this angle going to be right here? 50, right? Because an equilateral, or in a triangle, or right triangle, those two angles that are next to the right angle have to add up equal to 90. We'll see that more when we get into chapter 4. So it has to be 40 degrees. By the way, notice that if I had gotten this wrong, if I had done the inverse tan of 5 divided by 4.2, you would have gotten 50 degrees, not 40 degrees. And then you would have said, oh, there's the answer, and you would have circled it, and you would have moved on, and you never would have thought that it was wrong. But in fact, it is wrong, because it's not tau, it's TOA, right? Emily? Elena. Shoot. You're Emily. Elena. Oh, yeah, the one that I botched? That one? I'm such a critic, huh? You said you're such a critic. No, I know, I said that. This one right here. Yeah, I messed it up in class because I think I told y'all that this, let me, because I told you that this was 400, when in fact it's not, right? That really, the hypotenuse was 400. What's your question though, Elena? So while you're thinking, I want to know what is y right here. That's the opposite. This is the hypotenuse. SOHCAHTOA. If I'm looking at the opposite and the hypotenuse, I'm going to want to do the sine of the angle. So I say sine of 15 is equal to y, that's the opposite, over 400. And so y is equal to 400 sine of 15. I did it incorrectly in class because, well, I did it correctly. I just did it assuming that this was 400, but it's not in this question. And then so if I want to know 400 sine of 15, that's like 100 and something, but it rounds down to 100. How do you know where the 400 is supposed to go? You didn't really. That's why I got it wrong, because it's just a poorly worded question. Okay, but it will be worded correctly in the exam, or the quiz. And if it's not, you can always ask me. The students ask me questions in the exams all the time. Now, I often don't answer them. I say, well, you just need to read the question, or you need to do this or that. But if there's a mistake in the question, or if there's something unclear, then I'll tell the whole class what that student asked, and I'll make it clear. Okay? So don't be afraid to ask questions if you feel like something's wrong. As I told you, every exam is fresh. Like every question is new on your exam. They'll be really similar to past exams, but nonetheless new. So sometimes just I make mistakes. I make a lot of mistakes, but I try to not let them seep through to your exams. Okay, I think this is your last one. I'm joking. You can ask me any question you want.
Can you show me how you move the equation to capital Y on the other side of the equation?
Yeah. So starting right here, you can think of this, probably the easiest way to think about it is that I want to get rid of that 400 on the right-hand side. So I multiply that side by 400, but if I multiply that side, I have to multiply this side by 400, and this cancels with that 400 just leaving me with y on this side, and then 400 sine of 15 on the other side. We're going to do this a lot in chapters 3 and 4 when we get into vectors. So that's why I want you to master it now, how to figure out the different sides of the triangle using your trig functions, because it's going to have to be second nature when you get to it in chapters 3 and 4. Madison? Yes, Madison?
When you plug it into your calculator, the 400 can't be behind the sine of 15, right? That's right.
It doesn't matter. You just have to be careful that you could do 400 sine of 15. You could do sine of 15 times 400, but you have to be careful that this is in parentheses so that that 400 is not brought into that sign. So you can write it either way, you just have to be careful with your order of operations and that your parentheses are set properly. Like I said, we're going to do this so much in chapters 3 and 4, that it's just going to be second nature for you, how to find the components of vectors. That's what we're doing here, is finding the component, which is really just finding the side of the triangle in the x or y direction. That's a good question. Sorry that I messed that up today. You can take it out of my paycheck. I don't know what that's worth. $5 maybe? Maybe it's a $5 error. Okay, what else, y'all? Particular questions? Kennedy?
There's no kinematics on this quiz?
No, only chapter 1. So if you get to a chapter 2 question, which for example here, you can tell right here, it's usually the first 10 or so questions are all chapter 1. Which means that, like I said, your quiz is going to be 8 to 10 questions, so it'll be most of those questions similar to the chapter 1s on the old exams. You'll have 15 or 20 minutes to do the quiz. I'll try to pick questions so that they're appropriate for that. But it's going to be a quick pace, so you're going to need to be pretty good. You have to know it cold. You're not going to have time to sit around and say, oh, how do I do this? And scratch your head and think for a while. You're going to have to move from question to question with just 1 to 2 minutes per question. That's important. It's not just important for this class, it's important for your various standardized testing and just as you move forward. It's a good test-taking skill. So get it right on this quiz. That means you need to practice, 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 and you know the questions. So if you're just memorizing questions, I'm okay with that. There's 150 or so questions for you to memorize that could possibly be on this quiz. If you do that, more power to you. But really, you want to learn the procedure. That's the easier way for you. Okay. Let me pause, and then I'll tell you all the answers that are on the